Today we're going to be doing, for the first time, ionic and net ionic equations. And we're going to find out what spectator ions are, and we're also going to see how those differ from the ions that are not doing anything that has to do with the reaction at all. They're only there to help the actual participants get into the water. Okay, so you have to have this little sheet. If you don't have it, I passed it out in class, and it will be exceptionally helpful for you because you may not be familiar or understand or remember the names of these ions. And we're going to be using this throughout this discussion. So be sure you have it handy. All right, and let's go right into the first example that I gave in class of how to do tonight's homework. So we're going to start out with the we. What's the we? Word equation. Okay, so if you look here, you'll see I'm talking about sulfuric acid and sodium hydroxide, and then that's going to give us, when we mix them together, will give us the sodium sulfate, and the product that makes all the difference in the world is the water. Okay, because that water is a liquid. Because it's a liquid, it drives the reaction. And this guy will never be written as an ion. It will always be written as water, and I'm going to rewrite that. And I wrote it this way on purpose because I want to be sure you know that that is water. Because first time that I saw anybody using water that looked like this, I thought it was something else. Okay, that's a long time ago now, but first time I looked at stuff, it was a long time ago. So what you want to do is get this down as your word equation, just like we've done in the past. No big change from anything we've done. What we do next is we use that sheet that I was just showing you, and we're going to get the names of the ions. So sulfuric, or the formulas for the ions, so that we can write the balanced equation. And so the balanced equation would be sulfuric acid H2SO4. If you look at the bottom of that sheet, you will see that. If you go to the sodium hydroxide here, and let's get a pointer up here. So now we have a pointer, and I can point to the name and then down to the chemical formula. So if you look on the sheet that I was just showing, if you look at the very top, you'll be able to see, and I'm pointing to the periodic chart right now with my class. At least I hope I am. Where is it? Here it is. Okay. I'm pointing to the first column of the periodic chart. And in the first column of the periodic chart, your charge is always 1, and sodium is in that column. So this sodium is going to have a 1 plus. And I'm going to call on some people to give me the charges of the polyatomic ions. So Aaron, how about it? What do we have? Okay, well, yeah. What do we have for this guy? You'll find that in column 1 of the chart in the middle. Speed things up. Now that we have a pointer, we can continue. Oh, goodness. So, anyway, this 2 here is part of the balancing, and the sodium is part of the sodium hydroxide. The OH is the other part, and this sodium is a 1 plus, and we know that from using our little chart at the top of the ions and acids to memorize chart, and then we look for hydroxide in the middle, and we see that he's a 1 minus. So what we have here is a balanced molecule because we have 1 of the 1 pluses and 1 of the 1 minuses, and when these guys are equal, we have a net zero molecule, which is what they always have to be able to have no charge. And these guys have no charge as a balanced molecule. And let's get rid of And now we go over to the next part, and we'll see that we have sodium now with sulfate. Over here it was sodium with hydroxide. And this is aqueous again. And the last guy is the water. So the water is the liquid, and you see OH. If you write water this way, you will be able to see the hydroxide ion and know that that's coming from here. So this hydroxide ion got together with the hydrogens from the sulfuric acid, which is this stuff, and we got two waters, and they are the liquid that makes this reaction run. So let's go now to look at what is the ionic equation going to look like. And I want to do this a little piece at a time, especially for the people at home, because they didn't see this the first time I did it without recording. At any rate, this hydrogen is 2 times 1 with a coefficient of 2. Coefficients are used to tell you how many of an ion you have, as opposed to using a subscript of 2. So these guys are always 1 ion and a number out front. Okay, and the aqueous has to be brought down here because we have aqueous up here. And now we look at the sulfate. That's the other part of the sulfuric acid. You have the sulfate ion as aqueous, and then we have a plus, the next guy. Sodium and hydroxide come from this guy. And the sodium is a 1 plus. Hydroxide, when you look at it on the chart that we saw at the beginning of the video, is going to have a 1 minus. And again, both are aqueous because it's aqueous here. And on the other side, sodium, instead of being with the hydroxide like it is here, is now with the sulfate. So this sodium got together with this sulfate and gave us our sodium sulfate, but this is still an aqueous solution. So we have 2 sodiums here because 2 times 1 is 2. We have 2 sulfates here because, here, let me see if I can get this out of the way. There we go. We have 2 sulfates here that are aqueous, and that's because of this guy here. And, oh, just 1 sulfate, I'm sorry, because we have a coefficient of 1 and no subscript for the sulfate molecule, which is made up of 1 sulfur and 4 oxygens. Now the last thing we're putting in here is the water, and that is the guy that makes this reaction go. And you see there's 2 waters, so we have 2 HOHs, and it's liquid. Now when we get in to write our net ionic equation, what we need to do is we need to look at this side of the equation where we have either solid, liquid, or gas. In this case, it's a liquid. And because it's solid, liquid, or gas, we are going to be able to put that on the right side of the equation. And let's get this so we don't see too much of that and make it confusing. So here's our HOH right here. And there's 2 of them because the coefficient here is 2. So we're forgetting about our, you could cross them out, but I prefer just to, trudge forward and look for the guys that this is made out of. So what are the 2 ions that we have here, folks? Okay, I've got to call people. Anthony, what do you have? Asleep. Jesus, what do you have? What are the 2 ions here for this guy? No. Hydrogen and what is this guy? What's the name of the ion? What's the name of the ion? So, okay, hydroxide. So it's hydrogen ion and hydroxide ion came together to form the water. Okay? And so we look for those in the balanced equation, the balanced net ionic equation. And so we have 2 hydrogens and 2 hydroxides, just like we did in the complete ionic equation. But what's wrong with this? Do I have the lowest possible ratio? I do not. And so because I don't have the lowest possible ratio, what can I divide these guys by? 2. Okay, and that makes the final numbers so that we have one hydrogen ion gets together with one hydroxide ion to form one water molecule. That's what's going on with all of this stuff that we had to write. Okay? So your homework is going to be done exactly this way. We have, and this is the net ionic. Let's get that uncovered. There you go. And so we have the the B, word equation, balanced equation, ionic equation, and net ionic equation. That's the easy one, right? That's the short one to write. Okay, here we go. Next one. Did we look at this yet? I don't think we did. Here, let me get the pointer here. Copy. And let's go back. So here's what we need to understand. Product for a net ionic equation will only be a solid, liquid, or a gas. Nothing else. Never ions on the right side of the net ionic equation. And if you look back here, you will see the right side of this equation, there's no ions. Okay, the right side is our water. The left side is 2 ions. And generally it's going to be 2 on the left, as you'll see in the examples that we're going to continue to do. All right, now you need to get out a piece of paper in the top right corner. You want to label it with your name, date, and period, because this is your homework. We're doing it now. We're going to do number 33. And let's get this guy so I can point. And that silver is a transition element. And so you can't really depend on what his charge is going to be. Let's see if I can make this look right. Well, this goes superscript to be up there with it. Oh, yeah, that's better. Okay, so your silver has a 1+ charge. Transition elements are the bad boys. They just don't follow any rules that we can figure out without so much education that you guys would never ever go that far with chemistry. So it's just suffice it to say that it is a 1+, and that's important because you don't know how this thing can be put together without it. So we have potassium iodide. This is copied right out of the textbook, by the way. So with your word equation, you can shorten it up and you can just say potassium iodide and write it with a S, and I just went straight for the balanced equation. But I would write the S subscript here because we have these words right here, aqueous equations, aqueous solutions. Okay, and I'm going to make this the we. And so we have potassium iodide, silver nitrate, silver iodide, and that's our first product. That's the one that makes this go. Besides the silver iodide, what's the other thing that we're going to have over here? We got potassium iodide and silver nitrate. Okay, the silver comes from this guy, and the iodide comes from this guy. So where's the potassium? That's what's going to be over here. Potassium. And what else do we have? Nitrate. Yes, the nitrate. And each of those has a 1+ and a 1- charge, NO3, nitrate, and we're good to go. So I'm going to write it down here as the balanced equation, the BE. And please label it. You don't have to say with subscripts because we're going to see your subscripts. Okay? And here is the balanced equation from the word equation. So what we're seeing is aqueous because aqueous is mentioned up here. and this is a solid. That's a code name for precipitate. Okay, which means it's chunk in the water is what I refer to it as. And then the last thing here is the aqueous potassium nitrate. Now with these aqueous dudes, we carry them down into the ionic equation. So here we go with the ionic equation. Potassium is a 1 plus. You'll notice that all my coefficients are 1. The ratio here is 1, 1 to 1 to 1 to 1, and we don't need to write the ones. If we don't write the ones, they're assumed to be there. So I have 1 potassium, no coefficient. I have 1 iodide. Now iodine is in column 17 of the periodic chart, and potassium is in column 1. So column 1, the dudes are always 1 plus, and you'll see that on the sheet that I showed you at the very beginning of the video. It's the charges for the elements that are not polyatomic ions you can get from the column that they're in on the periodic chart. And that little chart is at the very top of that paper. So silver, the ion, nitrate, the ion, 1, 1, 1, 1, 1, 1, 1. Silver iodide is what we were told here, and we just figured out that we have potassium nitrate, so we have potassium here and the nitrate ion. Right. And now we go to the net ionic equation, and to do that we're going to start at the right. So Neville, would you tell me, what are we going to write down here? Silver iodide or potassium and nitrate ions? Look at the last example. And also reread this before you answer. So, what are we going to write? We're going to start our net ionic equation with what? On the right side. Silver what? Silver iodide. There you go. Okay? Now we're going to look on the left side to find these guys. Okay? Or, I'm sorry, to find these two. Okay? The silver and the iodine. Okay, where are they? See them here? Little aqueous dude, and the iodide, little aqueous dude. And that gives us our complete net ionic equation. I shouldn't have said complete. This is just net ionic equation. So we have silver as a 1 plus, aqueous, iodide, as an aqueous with a 1 minus. And our product is silver iodide as a solid. We didn't have to reduce the subscripts at all because they're all 1 already. Nice little coincidence. Okay, let's go to 34. 34, here is the way I would write the word equation, aqueous solutions of. So I would write ammonium phosphate, and let's do that. Let's do this a little bit differently than we did the last one. Yeah. Let's put the subscripts in. Okay, so this is going to be aqueous. Oh my. Let's get that right. A, Q. Q. Oh, jeez. A, Q. There we go. Slow down a little bit and everything works better. All right. Plus sodium sulfate that is also AQ. And there's no precipitate and no gas. You're going to find out what that means. You're going to like it, actually. Okay, so let's go ahead and do our ionic equation, our balanced equation first. Oops. Yep. Do we have it on? There we go. Let's do it one line at a time. Sort of. There we go. There. All right, now that's a little easier to follow. So I know that I have ammonium phosphate. Phosphate, if you look on your chart, is a 3 plus, or 3 minus, I'm sorry. Ammonium, if you look on your chart, is what? Class? 1 plus. And so that's why we need 3 of these guys. This guy carries a 1 plus charge, which means we have only 1 phosphate. And phosphate is a 3 minus charge, which means we need 3 ammoniums. And that gives us a net 0 molecule. And then when I balanced it, I'll tell you a little trick that I used to make that balance. But sodium is a 1 plus, sulfate is a 2 minus, and you find that on your chart. And, oh, we're just about out of time. And then the ammonium sulfate has 2 ammoniums and 1 sulfate. Now watch what I did to balance the equation. This is a 3 because of this subscript. Okay? This is a 2 because of this subscript. I'm balancing my ammoniums. And then we have this guy in balance because he's two pluses because sodium's a 1 plus and sulfate is a 2 minus. Okay, when I stopped, I let my class go, and I'm not sure exactly where I left off. But what we were doing is taking these guys apart and making these guys. And I think I got to here, and we're going to go down from here to get the right side of this complete ionic equation. And of course that means we're pulling these guys apart, okay, ammonium and sulfate, and then we're also pulling apart sodium and phosphate. And because we're doing that, we're winding up with these guys down here. Again, 2 times 3 is 6 sodiums, and 2 times 1 is 2 phosphates, and 3 times 2 is giving us the right number of ammoniums, 6. 3 times 2 is 6. And then 3 times the sulfates is 3 sulfates. And here we write them with the charges. We never write charges when we are in the molecule itself. Okay? So this we call the ionic equation. Now, we have a very interesting situation with this guy, and this is really where we learned chemistry. Okay? No precipitate, no gas, no net ionic equation, because nothing will drive this guy to completion. Okay, so this is it. Once we get the right side of the equation, we're done. And what we need to write is the net is the net. The net ionic equation is the same as the ionic because there is no reaction. And the reason that there's no reaction, is because no precipitate was formed, and no gas was formed, and no liquid was formed. Nothing was formed. So everything stayed as it was in the solution, and it never went to completion, or it never even started, because none of these guys has a problem dissolving in water. And let's call this the net ionic. And then everything is good. This is the way, I'm hoping that this video helps you in doing your homework. And if you weren't here today, you certainly have a big leg up on not having this video. So I hope this helps everyone, and thank you for watching.